this is what I told you to do. Rate of reaction, order of reaction, molecularity, and integrated rate equation. This is what I gave you. The questions on these topics are very easy, basically. Let's start. Should I give some overview of this? So I'm going to give some overview of this, okay?
Okay, sir.
For chemical kinetics. So see, first of all, when we are going to talk about rate, you know that rate is equal to change in concentration of either reactant or product divided by time taken to change. So basically, when we are going to write, the rate will be equal to minus delta of change in reactant upon delta T, or either you can write plus delta, P means product, upon delta T. So basically here negative represents decrement in reactant, concentration of reactant, decrement in
So
concentration
replaces
of,
the product rate.
yes, concentration of reactant, and positive shows that increment in concentration of reactant, increment in concentration of product. Basically, you know that when a reaction is going to start, initially you will have some concentration of reactant, but initially the concentration of product will be zero, and then it starts suddenly appearing. So there are two things that you need to take care. That the first one is the rate of appearance. Just wait a minute. Hold on a minute, please. Okay, sorry. Am I audible to all of you? Okay, so
Yes,
I
sir.
was talking about rate of appearance, and there is another term that is called rate of disappearance. Just wait a minute. Rate of disappearance. Okay, and here comes rate of appearance can also be known as formation. So from the term you can see appearance or formation we generally use for what? Product, because product will start appear or form, and disappearance is for reactant, right? Reactant. So basically, if I'm going to start, take a general equation, like let's say if we have AA plus BB, that is giving you CC plus DD. So in terms of appearance and disappearance, first I'm going to write for this rate of, since it is reactant, so I'm going to write disappearance. The rate of disappearance of A will be equal to minus change in concentration of A, change in concentration of A upon delta T. Change in concentration of A upon change in time taken during that. Then rate of disappearance of B, that will be equal to minus delta of change in concentration of B upon delta T. In the same way, we can write for appearance, the rate of appearance of C will be equal to positive change in concentration of C upon delta T, and then again a rate of appearance of D will be equal to plus change in concentration of D upon delta T. So basically in appearance and disappearance, we don't take the value of stoichiometric coefficient. And appearance, rate of appearance and disappearance can have different value. But when we are going to talk about rate of reaction, generally we write the rate of reaction in terms of stoichiometric coefficient. Is that clear?
Sir, so here we don't write stoichiometric coefficient, right?
Yeah, we don't write stoichiometric coefficient for rate of appearance,
Okay,
disappearance
sir.
can be different. Okay. Now, when we are going to write rate of reaction, when we are going to write rate of reaction in terms of stoichiometric coefficient for same
So we
reaction.
divide, right?
Yes, AA plus BB, that is giving you CC plus DD. So negative will be there for reactant, and whatever is the coefficient that come into denominator, change in concentration of A divided by T, delta T, that will be equal to, since for B, minus 1 by B, delta B upon delta T, that will be equal to plus, since we are going to talk about product. So plus, whatever is the coefficient you are going to write in denominator, change in concentration of C upon delta T, that will be equal to, again, another product 1 by D, change in concentration of delta D upon delta T. And this delta can be written with D as well, dA upon dt. Are you getting my point? Basically, this delta we use for big change, and D we use for a small change, very small change. Or you can say this D we use for instantaneous, and this delta we use for average. Like if you are going to calculate average speed, so delta V or dV is the instantaneous velocity. Are you getting my point, all of you?
So sir, in place of delta, we replace D.
Yes, replaced by dV, same thing.
Okay, sir.
Okay, in when we are going to do the derivation of integrated rate equation, we use D, so that you will be able to understand D in integration and differentiation. Is that clear, all of you? So if someone is
Yes.
going to give you 3 by 2a plus 5b, is giving you 1 by 2c plus, let's say, 2d. So what will be the rate of reaction? The rate of reaction will be equal to, first of all, for this minus. And I told you 1 upon 3 by 2 it will be. So can I write 2 by 3 d of
Yes.
a upon dt? Or you can write delta A upon delta T. That will be equal to, again, this is a reactant, so minus 1 by 5 delta of B upon delta T. Then your comes product plus 1 upon 1 by 2, that becomes 2 delta C upon delta T. Then comes your plus 1 by 2 delta D upon delta T. I think it's clear to all of you. The rate of reaction formula. This is how we are going to
Yes.
write. So can I change the slide? Can I change the slide? It's just to revision your.
Yes.
This chapter is already done, right?
Yes, sir. It's done.
Okay. Now see, there are some terms. One is your molecularity. Molecularity is basically is a theoretical quantity, not a practical theoretical quantity or theoretical concept. It's better theoretical concept. And you know what it is? Basically, in reaction, how many molecules are reacting? That is your molecularity. Like for explanation, I can write 2H2O. If I have written in this reaction and it forms like 2H2 plus O2, 2H2 plus O2. So what does this mean? How many molecules are reacting with each other? Two molecules, right?
Sir, it's 2 moles, right?
So this is bimolecular. This is bimolecule. If in a reaction, if I have written HI, that is converting itself into half H2 plus half I2. So how many molecules are interacting with each other? How many molecules are interacting or reacting? Only one. So this is called
One.
molecular. Okay. It cannot be, it can't be zero, negative, or fraction. Is that clear?
Yes, sir.
Okay, moving to the next one, that is your order of reaction. Very important. This is order of reaction comes from a rate law expression. A rate law expression. What is this rate law expression? Very simple it is. The rate law expression is defined in terms of a reactant,
Reactants.
in terms of reactant, not product, in terms of reactant. Basically, if a reaction is given as AA plus BB, that is giving you in any product P. So rate will be directly proportional to the concentration of all the reactant. There will be in multiplication raised to the power something. Raised to the power something, that what something that is, I will tell you. And to remove this proportionality sign, there will be a constant that is called velocity constant, as a specific rate, or the most common is rate constant. What it is called? Rate constant. And rate constant only depends upon temperature. Only, we are talking about K, so only depends on temperature, nothing else. Okay. Now come to this X and Y. What is this X and Y? X, basically X and Y may or may not be equal to, may or may not be equal to its stoichiometric coefficient. Its stoichiometric coefficient. So basically, X can be equal to A or B. That depends upon the type of reaction. Very simple it is. If any reaction is elementary reaction, if the reaction is your elementary reaction, that means single step reaction, single reaction, simple reaction, elementary reaction, then the power of concentration of reactant, concentration of reactant is equal to its stoichiometric coefficient. Stoichiometric coefficient. Please write this point. Very important it is. Let me know when you are done with this. Like you already have notes of this. I'm just giving you overview. Can I change the slide?
No, sir, 1 minute.
So in elementary reaction, only the coefficient will be equal to power, and in complex reaction, you will have to find out according to the mechanism of the reaction will be given. According to that, you need to find.
Yes, sir.
Very good. Now see, when you are going to talk about, I didn't explain what is order of reaction. So if rate law expression is like rate is equal to k into a raised to the power x into b raised to the power y. So this x is your order of reaction. Try to understand order of reaction with respect to E, with respect to E. And Y is order of reaction with respect to B. But what is order of reaction? Either it can be called order of reaction or either it can be called overall order of reaction, overall order of reaction. And this will be equal to the sum of all the powers, x plus y. And order of reaction denoted with n. Order of reaction n can be zero fraction as well. Okay, and negative as well. And this is a experimental quantity. Like uh, you know that this is experimental quantity. Molecularity is not an experimental quantity. It is a theoretical concept, and this is your experimental concept. Okay. So if someone is going to give you rate is equal to k into a raised to the power half into b raised to the power 3. So what will be the order of reaction? You just need to add the power and you will get the answer. So it becomes 7 by 2. Are you getting my point? Is that clear? Please do respond. Can you change the slide? Please tell me. Are you writing all this in your notes? It is available, I think, right? Okay. Tell me the order of reaction. If rate expression I'm going to give you e raised to the power 1, b raised to the power 2. Just wait a minute, not like this. Right order of reaction. These are all elementary reaction. If it is given in a singular step, it is all elementary reaction. B is in excess. Give some products. Elementary reactions are. Understood all of you? So very simple it is what I told you. This is your elementary reaction. So rate will be equal to K into A raised to the power whatever its stoichiometric coefficient. B raised to the power whatever its stoichiometric coefficient. So can anyone tell me what is the order of reaction now? Fadil, Savez, Harif. No answer from anyone.
Yes, sir.
What is the order of reaction?
Sir, 5.
5. Very good. So in the same way, please calculate the order of reaction for this. So if you're going for this, you're going to rate is equal to K into A raised to the power 1. B, I'm going to write it as it is, and C raised to the power 1. As you can see, this is 1 and this is also 1. Always remember that whenever something is in excess, the power will be 0. The power will be 0. Basically, it won't affect. Let's say whatever you like. Let's say if you like that anything you like any chocolate, and if you have millions or trillions of chocolate, that means it is in excess. So will you be able to complete that chocolate? Like practically thinking like 1 or 2 or 3 or 4 or 10 you are going to eat, or 20 in a day, or 100. So basically whenever you are going to uh, have anything in excess, you are going to take the power as 0. This will be as it is. So when you are going to sum, you will be getting second order. Is that clear? So zero order is that in which the amount is in very excess. Excess it is in. Is that clear? Everyone. Now there are
Yes, sir.
integrated rate equation for zero order reaction. Integrated rate equation. So you didn't, you all of you didn't revise that. There is a formula K is equal to R naught, that means initial concentration, minus R, that means final concentration of reactant, divided by time taken to reach this position. Okay. For T half, there is a formula R naught, initial concentration, upon 2K. K, you know that rate constant. R naught is your initial concentration. Initial concentration. R is your final concentration. Final concentration that is left in the reaction. K is equal to rate constant. Rate constant. And this both is for zero order reaction. What it is for? Zero order reaction. Now, what is for first order reaction? For first order reaction, K is equal to 2.303 upon T log of initial concentration R naught upon R, final concentration. And for T half, it will be equal to, if you are going to see the derivation, you will get it 0.693 upon K. So these formulas that you have derived in the class, you should remember it in order to get the correct answer. Is that clear?
Yes.
Please do write it. You know when you're done with this. Yeah. So moving to the question, please do revise whatever topic I'm gonna give you. Otherwise, it will be very tough. The question is started from here. The question on this topics are very easy. You should know how to apply the formula.
Yes, the CBSE question.
Now, what did you say?
Where are the CBSE questions?
Have you done CBSE question?
Yes.
Okay. Similar questions are there.
Okay, sir.
Any answer? So you will see, I'm going to explain very easy it is. The rate constant is given. That means K is given. The time required to reduce 2 gram of the reactant to 0.2 gram. Very simple it is. This is your initial concentration. And this is your final concentration. For first order reaction, what is the formula for first order reaction? I just gave you the formula for first order reaction. K is equal to 2.303 upon T, log of initial upon final. We need to calculate time. So time will be equal to 2.303 upon K has a value 4.606 into 10 raised to the power minus 3. Log of initial concentration, that is 2. Final concentration 0.2. So I think very good, Harith. So what it will be, this will be cancelled by 2 times, right? So it becomes 1 by 2 into 10 raised to the power 3. And this will be cancelled, 10 will be here. And log 10 has a value equal to 1. So basically, this will be the scenario 0.5 into 10 raised to the power 3. That means 500 seconds. Isn't it easy? If you know how to apply the formula, the whole chapter is very easy. Is that clear, everyone? Go for the next one. This is the option for question number 3. Very good, Tharif. So I just gave you formula for the rate constant for first order reaction is K. The time required for completion, 99% of the reaction is, oh, it's wrong, Tariq. 99% reaction. This type of question is very easy. You know what? We need to you need to calculate T in terms of K when the reaction is 99% completed. So let's say initial concentration R naught is equal to 100. Okay. So final concentration will be what? 99% complete. That means 100 minus 99. That will be equal to 1. Yes or no? This is the initial and this is the final, right? Please do respond. Now you are going to apply the formula. T is equal to 2.303 upon K. Log of initial concentration, that is 100 upon final concentration 1. So what it becomes 2.303 upon K, and this I can write 10 raised to the power 2, and this 2 will be coming here and it becomes log 10. Log 10 has a value that is equal to 1. So when you are going to multiply this, you will be getting 4.606 upon K. This is the time to complete 99% of the reaction if rate constant is K. So the answer will be C. No one is responding. Savage, you haven't revised this chapter. Fadel. What is the answer for question number 3? This is also very easy.
1 minute time solve.
Question number 3, what is the answer? You need to calculate the correct option for this. So this is the rate of reaction given. So for this, you know that minus 1 by 1 it will come, and for this minus 1 by 3. So minus 1 by 3 is there, and this is minus. This is product, so you are going to put positive. So this is the incorrect option. This nitrogen is correct, but for this 1 by 2 it should be, so it will be incorrect. This is also correct, and for this it is plus 1 by 2, so this is the correct option. This is also wrong. For third, it's C. C is the correct answer. Is that clear, all of you?
Yes, sir.
Okay.
Why is hydrogen not given?
My voice is not coming. Did you say this?
No, sir. Why is hydrogen not given as the option?
Yes, yes.
Minus 1 by 3 is 2.
Okay. Can I change the slide?
Yes, sir.
Is there any answer for question number 5? Whenever the order of reaction is not given, so you are going to look at the unit of the rate constant. If it is K is equal to per second, if the unit of rate constant is per second, then it is first order. You have studied in the regular classes. If K has a unit mole per second, then it is zero order. Very simple it is. Yes, very good, Savage. Please do apply the formula of that zero order reaction. What did you say? No, not first order. It is not first order. It is zero order. Since the unit is mole per second. Now you can apply the formula of zero order reaction I gave you and get the answer. Any answers? Always, Tarif.
I'm doing 1 minute.
Very good, Tarif. Savage, what about you? Let me know if you're not able to do this. I'm going to show you this is zero order reaction, so you can apply the formula. In order to the rate constant, if the concentration of A is, what did you say? I told you K will be equal to R naught minus R upon T. So I can also write KT will be equal to R naught minus R. We need to calculate then concentration of B after 20 minutes. So first of all, what I'm going to do, this is the negative. If you are going to have R naught as 100 and final concentration, whatever is left. So if you are going to subtract this, then you will get the concentration of B. Very simple. What is the value of for this? 0.6 into 10 raised to the power minus 3. And what it is? 20. And since this is in second, so you need to convert this into second. When you are going to calculate it, you will get 0.72. This is the concentration of B that will be there. Or you can see change in concentration, initial concentration minus final concentration. Is that clear?
Yes.
Let me know about the question number 6. Okay, I'm going to explain the sixth one. Sixth one is also very easy. See, A plus B from this, what I can write, rate is directly proportional to
Sir,
A raised to the power
is it D?
100 and B, wait a minute. Yes, it is. Who said D?
Sir, sir.
Okay, so this is correct for both of you. Please do revise this. First order